This is Robert Sapolsky, and you're listening to Father-Offspring Interviews.
Hi there, welcome back to Father-Offspring Interviews. Starting off, Yash from the US asks, as a man with same-sex attraction, I have a lot of LGBTQ friends, and I've noticed many of the males did have overbearing and dominant or controlling mothers. Do you think attachment style with parents could influence sexual orientation and gender identity?
Well, all I can start off with is by saying, oy, since time immemorial, as in ever since the Freudians took over mental health care, there's been this notion that mothering style can influence a son's sexual orientation. Now, broadly, this took two pathways. First one, overbearing mother, over controlling, hypercritical, just in the son's face. And as a result, the son comes away so terrified of his mother as to generalize it to being so terrified of women that he becomes gay. Meanwhile, the other Freudians had a second scenario, which is the mother is so smothering and over loving and, get this, seductive. As far as I can tell from that literature, seductive means the mother would hug her son now and then, but so over mothering that as a result, the son would over identify with her being attracted to men, and off you go. Of course, in both of these scenarios, there's an extra piece of the story, which is either the father figure or the father is not actually there, or he's passive. And this is where the word emasculated tends to come in a lot. Now, you'll notice there's two problems with this notion that this is the roots of homosexuality. First problem is these are two mutually contradictory pictures of what sort of mothering style supposedly results in this. The second problem is this is sheer gibberish. And this has been clear for decades and decades. 1948, Alfred Kinsey was already documenting that there's no relationship between sexual orientation and parenting style. More formal studies were also starting in the 1950s, 1960s showing this. But then showing how bad this was in 1971, a New York Times article, I want to get these quotes exact here, so I've got it here, a New York Times article entitled Homosexuality, Parents Aren't Always to Blame. And here are some quotes from it. More careful studies are beginning to take mother and father somewhat off the hook. Sometimes parents inadvertently encourage such behavior by explicitly forbidding sexual encounters with girls, but saying nothing explicit about other boys. Weren't saying anything explicit about manatees or grizzly bears or something. The growing public tolerance of homosexuality, which may make some men feel maybe it's easier. Why not? So that was the New York Times in a time period where John Travolta, Meryl Streep, Robert De Niro were already coming on the scene, when Earth Days were already a thing. This is what the New York Times had to say. Fortunately, by all logic, this should have been completely trashed 2 years later, 1973, when the American Psychiatric Association officially decided that being gay was not a psychiatric disorder, and thus overnight millions of men were cured of a supposed psychiatric disease. This should have taken care of it forever. But here's a quote from 1980 from the British Journal of Psychiatry. The physician should feel free to relieve parents of guilt for this condition. Then, as recently as 2024, you go online to YouTube and a licensed marriage and family therapist is saying there are gay men who are gay because they were raised by a toxic, domineering mother. And nicely, the person sort of appended that with the end by saying, I don't actually have proof for this, but there you go. So what we got here is a long string of folk beliefs like black cats bring bad luck, or if you go swimming after lunch, you'll get fatal stomach cramps, or if you step on a crack, you're going to break your over domineering, over controlling, homosexual, ogenic mother's back. And what we now know since then emphatically is sexual orientation seems to be rooted in some interactions between genetics, prenatal endocrine environment. It's got nothing to do with the stereotype of the overbearing, overloving mother that was trashed more than half a century ago.
So, next are two related questions. Maria asks, can you talk about sleepwalking and if any other animals experience sleepwalking? And Erin from Montreal says more specifically, our dog not only barks, growls, and runs while she is asleep, but also sometimes wags or tucks her tail. But have dogs also been known to sleepwalk?
This uncovered a treasure trove of interesting factoids. Somnambulism, walking in your sleep, it's one of a whole category of parasomnias. Abnormal behavior during sleep, for example, sleep terrors, which a lot of kids have and typically outgrow. Then there's something called sleep-related eating disorder. Somebody in their sleep will suddenly gorge on food for a minute or two before going back to sleep. So sleepwalking, the characteristic of it is it's not in a dream stage. It's not when you are in REM, rapid eye movement sleep. It occurs during non-REM sleep. The person has their eyes open, they're glazed, their pupils are dilated. More characteristics, they have no memory of it later on. And typically, sleepwalking can stretch from 30 seconds to 30 minutes or so. Much like the sleep terrors, sleepwalking tends to wane in adolescence, but there's some people who do that lifelong. Now, what's really striking about it is just how elaborate some cases of sleepwalking can be. You've got people who cook meals, who drive cars, who wake up to discover they've cut their hair, sleep sex during sleepwalking, peeing in public, taking your clothes off in public. But probably most consequential are some things that can turn out to be extremely dangerous, which is violence. At least some cases of individuals, while they're sleepwalking, committing a violent act, murdering their partner in bed. This has come up a number of times in courts. And from what I can tell, it almost never works as a defense. I was sleepwalking. And this is probably for two reasons. First off, the jury just doesn't believe the person. And second, the person comes up with an explanation. I was dreaming that I was defending my family from marauding predators or something. And this is scientifically a little bit suspect because dreams are occurring during REM sleep and you get the sleepwalking during the non-REM sleep. Okay, so what are the mechanisms for this? There's evidence of a genetic component to it. If you have a parent who sleepwalks, you have about a 50% chance of this, which struck me that's normally interpreted as evidence for genetics, but this could also be just a kid wanting to model themselves after their parents sleepwalking. Nonetheless, the general sense is that there's a genetic component. Genome-wide surveys to try to identify relevant genes have not been terribly useful. Something else noted, studies looking at EEG recordings, electroencephalogram recordings, in individuals while they're sleeping, even on nights where they are not sleepwalking, but these are habitual sleepwalkers. And what you see is there's instability in the EEG recordings during the non-REM sleep. Make of that what you will. But probably the most insight comes from this wonderful quote, which is sleep is not necessarily a global phenomenon. What's this saying? Which is amazingly, you can have one part of your brain that is asleep while another part is awake. And this seems to be what's happening during sleepwalking. Part of the brain that is asleep exactly as it should be, hippocampus. Oh, yeah, which is why you don't remember anything afterward. The dorsolateral prefrontal cortex, which would normally be a part of the brain that might say, this is ridiculous, this tomfoolishness, go back to bed. it is asleep. What parts of the brain seem to be awake when people are sleepwalking? Motor cortex, cerebellum, amygdala, insula, perhaps giving some of the emotive aspects to sleepwalking. One last hint, when you do brain imaging on people who are habitual sleepwalkers, it turns out their brain is not quite as good at inhibiting their motor cortex as in other individuals. And the speculation is this has something to do with the shortage of the inhibitory neurotransmitter GABA. Okay, so what about animals? Animals do come into this. I discovered a 1788 treatise on sleepwalking that attributed it to animal electrical magnetism. And I'm not sure how solid that is held up with replication, but you see there's evidence of something kind of like sleepwalking in other species, noting we're the only species that actually is bipedal, but you see hints of it in dogs making movements during sleep that resemble running, that resemble walking. The one problem with that, though, and this has given rise to a great deal of debate in the literature, dogs are doing their walking, running like movement when they're dreaming during REM sleep, not when they are in the non-REM stage that's normally associated with sleepwalking. Okay, so it's just around at this point that we may start getting all arrogant as humans, saying, whoa, look at us, look at how amazing we are. We can have one part of our brain asleep at the same time that another part is awake. Look at us. And it turns out we are pikers compared to some other species when it comes to having one part of the brain asleep and another part of the brain awake, something called unihemispheric sleeping. And it turns out the world's experts at this are birds. Not all birds. And when birds are just sitting there on the ground or on a branch when they're sleeping the plain old regular old way. This is birds that are migrating, that are flying long distances over oceans so they can't touch down to rest because their wings get all wet and unaerodynamic for these long, long migrations, hundreds of miles, thousands of miles that the bird goes through without stopping. One hemisphere of their brain is sleeping, while the other is wide awake and following the rules about how brains are wired. If this is the side of the brain that is awake in this bird, that means that this eye is open and on the lookout for predators. And this is extraordinary. The most dramatic example that's been shown of this was a godwit bird that holds the record for a long distance migration. It flew over the course of 11 days nonstop over 8,000 miles from Alaska to New Zealand. And when you look at how amazing it is that one half of the brain was asleep at any given point, it seems even more amazing that the bird could go 11 straight days without having to rest. So, what's going on in the brains? It involves one additional phenomenon that is fascinating, which is called a group edge effect. And this was from a 1999 Nature paper, which was showing when birds are flying in a flock or even in a V formation, the birds on the outside of each V, the birds on this side, it's their outside left eye that's open, and the birds on this side, it's their outside right eye that's open. And so that they're watching out for predators and doing something altruistic for the whole V formation. And that's totally amazing. The paper that showed this, I tried to figure out how they discovered this, and all I could find was the statement that the test subject birds were arranged in a row, which all that does is make me think of Anne Geddes pictures. So that's what's going on with the birds. What's happening in their brains? Something really interesting. Birds that do this long distance migration and sleep with one hemisphere at a time, their corpus callosum. This is a branch, an arch, the bridge of fibers connecting the two hemispheres to each other. And that's integrating hemispheric function. Turns out these birds that do this, they still have a corpus callosum, but it's a lot thinner than in other bird species that don't do this. Makes lots of sense. What also makes lots of sense, part of the brain called the locus ceruleus, There's two of them, one on each side, and they project to the rest of the brain, and there's some degree of overlap. What does the locus ceruleus do? Arousal, emergency, alertness, waking up, and norepinephrine, noradrenaline. And in these unihemispheric sleeping birds, is there's less overlap. In other words, you can activate the locus ceruleus on this side so the bird is wide awake and paying attention while the other side is sound asleep. So that's cool, ways in which the two hemispheres are not integrated in these birds. But then you also have some of the opposite, because when this is going on, the hemisphere that is awake, instead of merely controlling the wing on that side, it's got to be controlling the wings on both sides. So some parts of the brain, the hemispheres are atypically separated. Some parts of the brain, you have one hemisphere having control over both sides. Now, something that struck me is an interesting part of this. I don't know if anyone has studied this, but if not, this is a subject just waiting to be studied. So you got this bird that's migrating, and at any given point, it's only getting visual information from one eye. There's got to be some sort of correction so it's not being pulled off course. And that's happening in the brain, which sounds like very unlikely, but research on bats when they were diving down to snag some insect that they were finding by way of echolocation, waves coming back to their ears. If they were diving down fast enough, their ears would flatten out a little bit from the velocity, and their brain had to do a correction for the flattening of the ears. So it seems quite plausible that the brains of these birds know which eye they are relying solely on at any given point and putting in some sort of correction factor. Okay, so that's birds outshining us in terms of half their brain is awake, half the brain is asleep while they were doing this long distance flying. Then it turns out you see the exact same thing in cetaceans, dolphins, porpoises, sperm whales, orcas, in pinnipeds, in dugongs, and manatees, the same exact thing. One hemisphere is asleep, the other one is wide awake. So, what's this about? Is this like so they could look out for predators 24/7? I don't think that's a big issue if you're an orca. Is this because they are migrating enormous long distances? And some of these orcas do this, sperm whales do this, manatees do. Oh, that's why I free associated manatees before. Manatees do this, but dugongs do not migrate. You got a dugong in your bathtub, it's not going anywhere. It's got nothing to do with predators. It's got nothing to do with migration. It's so that at any given point, when the animal is sound asleep, with half the brain, the other half of the brain is keeping track, time to bob up to the surface to get some oxygen. That appears to be the mechanism for it. So you also have that same group edge effect in dolphins when half their brain is sleeping. You remember with the birds, the eye on the outside is looking out for predators. Interestingly, in dolphins, it's the eye on the inside of the group that's wide awake. What is that about? It's so they can look at each other for social cohesion, because you know dolphins just love looking at each other and wishing each other well. So even when they're asleep, one eye is awake and allowing them to keep track of each other. Final factoid, turns out crocodiles sleep with one eye open. I have no idea if one hemisphere is asleep, other not, but why are they doing that? Probably seeing if somebody is smiling at him, and I would recommend you never do that.
And of course, we didn't even touch on sharks and their weird sleep systems. Many sharks don't have eyelids, which means that their eyes remain open or they roll them back into their heads while they're resting. And additionally, many types of sharks literally have to keep swimming at night in order for their gills to work. So they enter a similar unihemispheric sleep as all of these other species.
Wow, even creepier than some of these other examples, given that it's sharks.
Now, Dushan from Poland asks, how come certain species evolve to change gender due to seasonal changes like temperature in some fish? How do their genitals work?
Just fine. Thank you very much. Just not both at the same time. Yes, gender switching fish. You got hermaphrodites. boring, familiar hermaphrodites, where you have an organism that has both functional ovaries and functional testes going on at the same time. So you got regular old hermaphrodites. You also have pseudo hermaphrodites, which has an interesting historical footnote. Hyenas are pseudo hermaphrodites, which is a whole story on its own. But 2,000 years ago, for reasons lost to even the most avid historian, Aristotle got obsessed with hyena crotches and dissected a whole bunch of them and mistakenly concluded that hyenas are hermaphrodites when they're actually pseudo hermaphrodites, I say bitterly. Okay, so you got regular old hermaphrodites where they got both at the same time. What we're talking about here with fish is sequential hermaphrodites. And you see sequential hermaphroditism in snails and slugs and plants, which just seem too weird to contemplate, and in all sorts of fish. 500 different fish species show sequential hermaphroditism, which seems like a whole lot until you consider how many different kinds of fish there are out there. 1 to 2% of fish species are sequential hermaphrodites. Now, the striking thing about it is the variability. In some of these species, everybody is born male, and at some point, a subset of them become female. In other species, everyone is born female. A subset turn into males at some point. In most of these cases, it's a one-time deal that you transition like that. But then there's some species like swordfish where you can go back and forth over time repeatedly, and we will see what that is about opportunistically. There's also variability. In some of these species, there are both ovaries and testes, but one of them is dormant at the time. And in other species, you got one kind and it can then turn into the other kind. So, what do you make of the fact that sometimes in different directions, sometimes one direction only, sometimes multi-direction, different mechanisms for it? What this tells you is this evolved independently multiple times. Now, why should fish go about changing sex with some regularity, at least 1 to 2% of them? And the dominant model is the size advantage model. What it's about in fish species is there's a certain time of life where there's a big reproductive advantage to be one sex and not the other. And this is usually the time of life when fish are their biggest. In some species, being really big is a great time to be female because you can make a really large number of eggs. And those are fish species where everybody is a male when they're young. There's one single reproducing female with one male mating with her. And if she happens to die, that male turns into a female. And one of the other males there now becomes the breeding male. And you see this, for example, in clownfish. And that's what was going on with marlin and coral. Then you got species like wrasses, where when you're really big, it's a good time to be a male because these are species that have harem structures, that have male territoriality. And you see exactly the opposite. Everybody's born female. There's one male who is reproductively viable and he's got a whole harem there, and somebody eats him, and the largest of the females gets even bigger and turns into a male, and one of the others takes her place. So how is this working? How does this work? There is some physiology known about it, and you basically see two models. One is, as I noted before, you will have fish that simultaneously have both ovaries and testes, but only one of them is functional at the time. And at that point, you activate one and you inhibit the other. Alternatively, you've got these fish species where there's only one type of gonad at a time. And when things like this happen, you de-differentiate that gonad. It shrivels away down to its fetal form and then reemerges as the opposite type of gonad. And this could occur over weeks or so. And what you see is, in most cases, this is pretty cleanly demarcated. In some cases, you've got some residues of overlap. For example, fish species, when they transition from being female to male, they still have an oviduct afterward, and they use the oviduct for the sperm to travel through. So some sort of hybrid chimeric thingy going on there. So the question, of course, becomes what are the triggers for this? And it's social signaling. When the dominant male disappears, when the dominant female disappears, some sort of fish pheromone thing is now absent, and that triggers some sort of transition. For those who care about the details, it appears to involve an enzyme called aromatase, which normally converts androgens to estrogens, and it either appears, which accounts for the transition, or disappears, which accounts for the transition in some other species. And that's what you got. Why aren't all fish doing this? Why only 1 to 2% or so? And it's essentially only in fish species where there is a dramatic difference in the reproductive advantages of being very big. If it's one where there's no clear winning strategy, that's a species where you don't get sex switching. And the other is if it's not too expensive to hand in your old boring familiar gonads and now regrow them as something brand new, it's very costly. So it's in fish species where there's a big advantage to being very large, being one sex over the other, and where you can afford to do this. Final thing, amazing science fiction writer Ursula Le Guin, one of her most famous novels, The Left Hand of Darkness, involved a humanoid type species that were like fish that could switch genders, and that produced all sorts of interesting complications.
That's all we've got for you. I'm Offspring Sapolsky, and thanks for your continued support of science and the beard.